All right, let's reboot the history of the computer. We're going to trace its story, its real origin story, not back to the 20th century or even the 19th. We're going way, way back to a time and a place you probably wouldn't expect. Let's dig in and uncover the hidden code that completely rewrites the history of computing as we know it. So, when I say the word computer, what pops into your head? You're probably picturing glowing screens, maybe some complex circuits on a green motherboard, or perhaps you think of the steam-powered dreams of Charles Babbage in Victorian England, right? That's the story we're all told. It's a story that's all about silicon, electricity, and industrial age genius. But what if that's not the real beginning? Not even close. What if that's just the final chapter in a much, much longer story? What if the real origins of computation, of algorithms, automation, even robotics, were first written not in code, but with bronze and water, during the incredible intellectual explosion of the Islamic Golden Age? Okay, so our journey starts in 9th century Baghdad at the legendary House of Wisdom. Now, this was not just some dusty library. This place was an absolute powerhouse, an intellectual engine where the greatest minds from all over the world came together. It's right here that the software of our modern world was first, in a way, compiled. And that brings us to a word that every programmer uses literally every single day. Algorithm. Turns out it's not some modern tech term. No, it's the Latinized version of the name of one of the House of Wisdom's greatest scholars, Muhammad ibn Musa Al-Khwarizmi. His name is literally the code for how we solve problems. And here's the breakthrough. Al-Khwarizmi's work on algebra, or algebra, basically established the entire idea of symbolic computation, a repeatable system for solving problems step by step. He also pushed for using Hindu-Arabic numerals, which gave us positional data, including the game-changing concept of zero. At the same time, you've got his contemporary, Al-Kindi, using frequency analysis to crack codes. This was an early form of cryptanalysis, and it's the direct ancestor of modern data mining. This was the abstract logic, the software, just waiting for hardware to run on. And that hardware, it started to take shape thanks to three brilliant brothers, also in 9th century Baghdad, known as the Banu Musa. These guys took the abstract logic floating around them and gave it a physical body. They created some of the world's very first automated machines, translating pure logic into actual physical motion. The Banu Musa brothers wrote this book of ingenious devices that was basically a catalog of automation from the future. They were using things like conical valves as automatic controllers. Think of them as water-based logic gates. Seriously. They designed float sensors to provide real-time data input. And they even built fail-safe systems that would shut off if too much water was used, which is a perfect mechanical example of an if-then conditional statement. They were literally programming with water. What they really created was a closed-loop feedback system, a machine that could sense its environment with a float, compute a response based on water pressure, and then actuate a valve to change what it was doing. Sense, compute, actuate. Sound familiar? It should. That's the fundamental principle behind every single robot and automated system we use today. Okay, let's fast forward a couple of centuries. We're now in Al-Andalus, or what we now call Islamic Spain. The next big leap was happening here, led by an engineer named Al-Muradi. He was creating these incredibly complex machines, built not around water, but around a new kind of logic, the logic of gears. Al-Muradi was an absolute master of geared computation. He used segmental gears, gears with some teeth missing, to create intermittent stop-and-go motion. It's kind of like a pulsed electronic signal, but purely mechanical. He engineered these wild epicyclic gears, with gears rotating around other gears, to calculate complex mathematical ratios. And his amazing mechanical calendars, they were true analog computers, automatically processing astronomical data to track the sun and the moon. And look, this was not just trial and error. This formula right here shows you the incredible mathematical precision he was working with. He was encoding complex ratios directly into the teeth of his gears, proving that physical hardware could perform sophisticated, repeatable calculations long before anyone even dreamed of a vacuum tube. This brings us to the 12th century, and to a figure who is an absolute giant in the history of engineering, Ismail Al-Jazari. People often call him the father of robotics, and for good reason. Al-Jazari took all the ideas that came before him, algorithmic thinking, feedback control, geared computation, and he combined them to create something,
Well, something truly revolutionary. Al-Jazari's genius was in his toolkit. He didn't just perfect old mechanisms, he invented core components we still use. He pioneered the crankshaft, which is essential for converting rotary motion into linear motion, basically a motion processing unit. But his most game-changing invention, the one that changes everything, was the programmable peg drum.
And here's where it all just clicks into place. Get this. Al-Jazari built a musical robot band for his patrons. The music they played wasn't random. It was controlled by pegs on a big rotating drum. And by moving the pegs around, you could literally change the song. Historians of technology look at this and say, that's it. That is the world's first stored program mechanism. The program, the music, was physically stored on the drum. Just let that sink in for a second. A programmable machine where the instructions were physically encoded into a storage medium. That is read-only memory, ROM. Created in the year 1206. It's the exact same fundamental concept that powered early computers and your old video game cartridges, just separated by 800 years and a universe of different technology. So you have to ask, what happened to all this incredible knowledge? Did it just disappear? Nope, not at all. It was transmitted to Europe through translations of texts and through trade, especially in places like Spain and Sicily, and it basically lit the fuse for the Renaissance. When you lay it out on a timeline like this, you see this amazing, unbroken chain of innovation. In the 9th century, Al-Khwarizmi defines the algorithm. By the 12th, Al-Jazari builds the first programmable machine. Centuries later, you look at Leonardo da Vinci's notebooks, and they are filled with designs for robots that are clearly influenced by these Arabic texts. And that line of thinking eventually leads us right to the 19th century and good old Charles Babbage. The materials have changed, of course. We've swapped out bronze, water, and gears for silicon, electricity, and circuits. But the underlying logic, the principles of algorithms, feedback, and stored programs, that is a continuous thread that connects their world directly to ours. So the code we write on our laptops, the apps on our phones, the AI that's transforming our world, it's not some recent invention. It's simply the latest chapter in an incredible story of human ingenuity that began over a millennium ago in the workshops and libraries of the Islamic world. And that leaves us with one last big thought, doesn't it? Just as Al-Khwarizmi and Al-Jazari laid the groundwork for our digital age without ever knowing what silicon was, what foundational concepts are we creating today that will become the basis for a world we can't even begin to imagine? What will be our hidden code?